The first thing to check is the PSU, the pre-stretch unit. Because the PSU can stiffen up or even seize when not in regular use, a general check ensures that all moving parts are actually moving, turning and functioning correctly. This, in turn, will ensure that the PSU is applying the right amount of tension to the film. Remember also to check the tension in the PSU springs, in particular that they provide sufficient resistance, and replace if necessary. Remember, weak or damaged springs, dirty or worn-out rollers, will cause aquaplaning, film tearing, and uneven film application. Start by cleaning down the pre-stretch unit rollers. These need to provide the correct level of adhesion to grip and stretch the film properly, while also ensuring that the film does not stick on the way through the unit. High tack films can leave excess tackifiers on the surface of the rollers. This residue can accumulate over time, particularly at the top and bottom of the rollers. If these deposits are not cleaned off, any new film can stick to them, causing what we call spiral tearing, where the film tears diagonally from the top or bottom of the reel. To remove these deposits, you'll need a stiff brush and a good degreaser or white spirit. If you have rubber rollers, don't use petrol, as this can break down the rubber. If you have an older machine with rubber rollers, you might find that after cleaning the rollers, the tread pattern is worn or damaged. If so, it's best to install an alloy replacement. However, as a temporary measure, the pattern can be recut. This can be done with a tyre tread cutter or a small disc cutter. Start at the top and cut a groove approximately 2 to 3 mm deep downwards at 45 degrees in a clockwise direction while turning the roller evenly. Repeat this in an anti-clockwise direction to form a crisscross pattern. This will help grip the film correctly and stop what we call aquaplaning, where the film doesn't grip properly on the rollers and thus is applied to the bale incorrectly stretched. You should also check the gearing on the rollers. Over time, and after continuous use, wear and tear on the teeth of the cogs may cause the rollers to rotate incorrectly or slip, once again adversely affecting the stretch and application of the film. Make sure all the gears turn correctly and that they are also well lubricated, using the appropriate grease nipples on the gear housing. Make sure that the two reel holders will allow the reel to sit correctly and rotate freely. Check all turntable belts for wear and tear, and even if only one is damaged or worn, replace them all. Remember, badly aligned and worn belts will affect the film overlap. Check that the bobbins that keep the bale central on the turntable are turning freely. Check the turntable gearing for wear and tear. To do this, remove the chain housing and confirm that the chain and gearing are free from debris and moving freely. Ensure the chain is tensioned correctly and the gearing mechanism is well greased. Check that the cut and tie mechanism is working correctly and that the blades that cut the film after each bale are sharp. Otherwise, the film can snag or tear. Replace worn or broken blades. Also, check the sensors are not out of line and are working correctly to ensure that the wrapper table returns to the correct starting position after each wrap, ready for the next bale. When mounting a new reel, be sure that the tacky side of the film faces the bale. Similarly, always be sure to read any enclosed bale wrap instructions carefully. It's important that the centre of the reel and the bale are horizontally aligned. This ensures that all turns pass through the centre of the bale and that an even distribution of film is applied. On round bales, this will also ensure that the film passes over the centre of each bale. On this type of wrapper, the height of the PSU can be adjusted on the wrapper accordingly. This diagram shows the configuration of the McHale pre-stretch unit. The bale wrap film, seen here in red, winds around the brake roller number 1 and around the second roller. Roller number 2 spins faster to stretch the film. The two rollers are geared to spin at the right relative speeds and so apply the correct amount of stretch to the film. This diagram shows the configuration of the Kverneland pre-stretch unit. Roller number 1 is used as a brake on the film reel itself. Roller number 2 spins faster and thus provides the stretch on the film, again seen here in red. Once again, the two rollers are geared to rotate at the correct speeds relative to each other and to apply the correct amount of stretch. These are the two most widely encountered configurations of pre-stretch units. Before you start to wrap, ensure that the round bales are the correct cylindrical shape, otherwise the film will wrap unevenly and stacking may be more difficult. Equally, ensure that square bales are a good, consistent shape with straight sides. Now you're ready to check that you're applying the correct amount of film to each bale. This is called calibrating the wrapper. In other words, correctly adjusting all the variables that determine the correct amount of wrap is used and that it covers the whole bale with the correct number of layers. As all modern wrappers work at very high speeds, you can't actually see any of the adjustments you might have made that easily. So, to ensure you're wrapping the bales properly, you need to wrap some test bales to see if the calculations and adjustments are correct. Here, we'll be using straw bales for this process. There are two ways to check that the right amount of stretch is being applied. First, we check the correct percentage of pre-stretch. Bale wrap stretches lengthways or horizontally when applied to a bale. Too much stretch and the film may be too thin and offer insufficient protection. Too little stretch and you'll use unnecessary wrap and the bale may not seal correctly. So, to check that the correct percentage stretch is applied to the film, make two vertical marks 10 cm apart on the wound reel of film. Then measure the distance apart on the bale itself once the film is wound on. When marking the film, be sure to only use a whiteboard type marker and not one with an oil-based ink, as these can easily damage the film, leaving holes and causing tears. 70% stretch is used in more temperate, lower UV climates, where the film can be stretched more and still retain the required UV protection characteristics. In high UV climates, many users prefer to reduce pre-stretch to 55%. The gearing within the PSU dictates the percentage stretch when on the bale. When those same marks that we placed on the reel have passed through the PSU and onto the bale, for 55% stretch they should be 15.5 centimetres apart, and for 70% stretch 17 centimetres. So in this case, we ideally want a 70% stretch on the bale wrap, giving us 17 centimetres. When using black film, it's possible to use tape instead of a marker pen to mark the distances. The second method of checking the correct stretch is by checking the final film width, or neck down, on the bale. When the film stretches lengthways, it also reduces across the width. This is the amount the film's effective width has been reduced after the correct amount of pre-stretching. We know the width of the film on the reel is either 500 mm or 750 mm, so there's no need to measure that. To check this width on the bale, find the final wrap across the centre of the flat end of the bale and measure the film width, or neck down, to check the right amount of stretch. 750 mm film should be between 580 mm to 610 mm on the bale. while 500mm should be between 380mm and 410mm. If this measurement is significantly outside these guidelines, it's been overstretched and therefore not applied correctly, and so may not give adequate protection to the bale. If it's wider, the film has not been stretched enough, and the bale may not seal correctly. For an airtight seal on your bales, it's vital that you achieve a 50% overlap of each new layer or turn of the film over the previous one. This overlap and the high tack on the inside of the film help to seal the bale. As mentioned earlier, to ensure that you achieve this 50% overlap, the centre of the reel must align with the centre of the bale. For example, when we checked the neck down of the 750mm wide film, we found it to be 600mm. The corresponding 50% overlap is ideally 300mm. The basic rule of thumb formula for calculating the number of turns for covering each bale with 4 layers is: count how many turns it takes to cover the bale once, then add 1, then double the total. For example, if it took 8 turns to cover the bale once, add 1 is 9, and double it is 18. At 8 turns, stop the bale and mark the areas where the film has least covering or overlaps of film with a marker. You can use these sections later to check the correct amount of layers have been applied. The counter inside the cab is set to the required number of turns, in this case 18, and then it counts up to 18. Similarly, the formula to calculate the number of turns to achieve 6 layers is: count how many turns it takes to cover the bale once, then add 1, then treble the total. So, that will be 8 turns to cover it once, add 1 is 9, and treble it is 27. Experience has shown that for a small added investment in film, there are economic benefits to be gained by applying 6 layers to all wrapped bales. However, it's essential to use a minimum 6 layers on all bales where dry matter exceeds 50%, on all square bales, and bales made from coarse crops. Finally, always ensure your equipment is maintained and serviced regularly in line with the manufacturer's instructions.